we'll go through the charts and then have a brief summary of these two products. We will be going through the functionality in quite high level, and we are not going deep into the code level, but we will also provide links how to get started and links to the documentation of the product. Okay, so let's have a brief introduction. Qt Enterprise and Mobile provides these two options for creating data-centric user interfaces. Charts have been around for a bit longer time, and data visualization has been released as 1.0 release some time ago. Both of these products are based on same principles, so we are not thinking about showing static charts like in Excel, but we have focused on the development on creating components that enable creation of data-centric user interfaces, so that you can, for example, create drill down views for the data, so that you can start with the high level and drill down in the details. Also, one of the areas that we have been focusing is the look and feel. So we aim to provide inbuilt themes for a good look and feel, and then also provide functionality for customizing the look and feel for each of the customer's products. And of course, these both products have been specifically made for Qt and QML applications, so we provide both C++ and QML APIs for both of these. These are part of the Qt Enterprise and Mobile licenses, and they are provided as part of the licensing package, so they don't have any additional cost for the customers. Okay, let's look at the data visualization in a nutshell. Data visualization has been built on top of Qt 5, so there is no Qt 4 support. And the specific reason for this is that we wanted to take full advantage of the OpenGL and the Qt Quick 2 functionality in creating this component. The use areas that we have been thinking when creating this product is visualization of large quantities of data, and also we have been putting a lot of effort in providing a component that can handle quite rapidly updating data. In many use cases, the 3D data visualization can create a really compact way of presenting a large amount of data, and of course, providing a 3D view with shadows makes the user interface in many cases look really cool. And one of the areas is the user interaction, so we are providing also two-dimensional views so that you can splice the data to 2D view for better readability. And as mentioned, both C++ and Qt Quick 2 supported. And okay, charts is a bit more traditional way of presenting data. So popular line and spline and area and scatter charts are provided, as well as pie bar, and then a bit specialized box and whiskers chart. And then some of the chart types can be also presented in polar axis presentation. And as mentioned, charts works also in Qt 4. So I think the minimum requirement is Q4.7.4 and onwards. Also QQuick 1 and QQuick 2 are supported. And charts is based on the Qt graphics view framework. So let's dive into the functionality of these in more detail, and I'll hand over to Titta.
Okay, so now we will take a closer look at the two modules. First, we will familiarize ourselves with Qt data visualization. I will start with the features of what the module has to offer. And I'm going to show you the types of graphs there are available. And then we will also check how to interact with the graphs. Then there are some customizable features that I will cover last. The module has to offer 3D bar graphs, surface plots, and scatter graphs. For these graphs, there are methods, for example, for changing the bar, item, or surface mesh type, themes, and selection modes. These are all things to which I will come back to later on in this presentation. So let's see with an example what the 2D slice view of the 3D data means. Throughout this presentation, I will show you with examples what the functionalities are. And I'm not going to go into details with the implementation as they are all provided with the modules. The intention is more to give an idea of where to find information later on. So here we have the 2D slice view available like this for a surface graph. And you can use the selection mode here to display a row or a column in this separate view. When you select a single item, the row or the column is displayed and the original view is shrunk into upper left corner. The original view can then be restored by clicking on it. Data visualization uses OpenGL for data rendering, as Sami already mentioned. The recommendation is to use OpenGL 2.1 or newer. If OpenGL 2 is used, then you will get reduced feature sets, which means that shadows, anti-aliasing, and flat shading for surfaces are not supported. On QML side, you can select the rendering mode. Background rendering modes for QML offer slightly better performance over indirect rendering mode, but graphs do not then obey the normal QML set ordering and cannot be partially transparent. In other words, changing the rendering mode is always a question of performance versus quality. And as Qt Quick 2 makes use of a dedicated scene graph for its rendering, it's therefore the best choice for data visualization. And with data visualization module, you will get some good examples of Qt Quick 2 support. And here you can see a screenshot of one of those examples, which is the Qt Quick 2 bars example. Then to customizable axes. The same example we saw before shows also how you can change the range and then customize the axes like this. And you can also do it the same way for the rows. Qt data visualization has default handler for mouse actions and touch gestures. And if you wish to create your own input handler, you will have to disable the default one. And let's check here the custom input example. This shows you how selection is done on mouse over rather than by clicking mouse buttons, as it's the case with the default input handler. So here the information of the item under the mouse is displayed. The data visualization comes with 8 predefined themes. Here we have pictures of each of the themes. These themes are something that can be used as a basis when creating a custom theme. You can also create the custom theme from scratch if you don't want to use any of the predefined ones as a basis. For a series, you can just change the color and the gradient. And for multi-series, it's possible to define series-specific theme, and multi-series means multiple series in the same graph. And there's an excellent example of using gradients with theme. Let's take a look at it. So here you can see how each of the layers has its own gradient defined. So there's one for the ground, one for the sea, and one for the tectonic. The use of gradients here makes the graph appear more real. Next, we will cover data handling and selection, and we will also see how the user can interact with the graphs. As you probably know, the data comes in many formats. Data visualization module has proxies for bar, scatter, and surface that are inherited from QAbstract data proxy. There is also another example of a specialized data proxy, the height map surface data proxy, which accepts a height map image and generates a surface based on it. The example code here shows how to use basic proxy when the data is stored in this my data object. So first, you have here a bar graph and a proxy for it. And here we have defined a list of pointers for Q bar data rows, which are defined here. And so the predefined data for this example is stored to some my data. And the series object can own a single proxy at a time. An existing one will be deleted when another one is set for series. But then a graph can have multiple series. So for different sets of data, it's more efficient to change the series rather than reset the data in the proxy. And there's more information of data handling available in the documentation. Okay, then let's move to data interaction. I will try to show with an example how the rotation and zoom work. So this is the scatter example. With the mouse, you can rotate the graph like this and zoom it with the roller like this. Here you can also see how a single data item can be selected. The same can be done for a bar or a surface vertex, like the images here show. Now I will show you how a row or a column can be selected from a graph. So a row selection can be done like this, and then you can change it for a column. And here you can also see how the selection looks like in a 2D view. And as I showed you before, the original view can be restored by clicking on the small image. And this image on the right shows how the slice view would look like for a surface graph. Next, we will move to scene and item customization. The scene can be customized with some camera properties like preset, orientation, and zoom level. There is one active camera you can customize, and the light is always positioned in relation to the camera. And this example shows how the preset can be used. And here only a couple of choices are shown, but you can set the preset, for example, to front, to right, or to low. Right, then to item customization. Data visualization has some predefined mesh types for bars, items, and surfaces. Mesh type is used to define how an item looks on a graph. The same applies for bars and surfaces. The user can also set a file that defines the used mesh. For more variety to the items, a rotation quaternion can be used. Here is an example that shows the use of a user-defined mesh. The arrows in this example are rotated so that the position is tangentially to origin, and the arrow item itself gets its appearance from a custom mesh. Now we have covered the features of Qt data visualization along with some functionality. And next it's time to see how you can start development with data visualization. I will show you some information of installing the module and using it in an application. As with other Qt modules, the Qt Enterprise installer is the way to get the module. And when you have the online installer or maintenance tool, you can find the Qt data visualization under Qt Enterprise add-ons. After installation, you have the documentation and examples available. The examples can be found from Qt Creator with visualization tag. And the source code will be installed under the installation folder in Enterprise Add-ons and Qt Data Visualization. When you start with a new project, you can link against the module by adding Qt += data visualization to your project file. For C++ classes, these definitions are needed. Including Qt data visualization naturally includes the whole module, and you can also include just the classes you need from the module. And for QML types, you can import version 1.0 of the module. All right, that covers the main features and functionalities of Qt data visualization. And next, it's time to see what Qt Charts has to offer. I will show you first the chart types available. First of all, there are these two chart types that represent the information as a line. The line chart connects the data points with straight lines, and the spline chart connects them with a spline. And the spline is drawn by using QPainter path. By the way, for all of these chart types, you can find a basic example provided with the source code. And I'm not going to show them here because they are really simple ones. I'm just showing the images to give you an idea what the charts would look like. Next, we have the area and scatter charts. With the area chart, you can show the data as an area between two boundary lines. By default, the x-axis is used as the other boundary, but you can also define it to be something else with Q-line series. The scatters chart, on the other hand, shows the data as a collection of points. And here in this example, we have three scatter series represented in one chart. Then there is the bar chart, and as the name says, the information with this chart type is shown as bars. The bars are grouped so that the bars in same category are placed next to each other. With the series type, you can define if you want the bars to be horizontal or vertical. Additionally, you can define that the bars should be represented as stacked or percentage groups. Okay, then we also have the pie chart, which represents the data as slices. There is the basic pie chart and then the donut chart. The donut chart is basically just a pie chart with a hole in the middle. The whole size is something the user can define. Next, a more special chart type, the polar chart. This chart type shows the data in a circular graph, and the data is placed using angle and distance from the center. You can use line, spline, area, and scatter series with the polar chart to represent data. The axis types available for these series can be used with this chart, and I will cover soon the different axis types available. You can define the axis yourself and determine whether you want it to be used as angular or radial one. For angular axis, you can see the values around the chart, and for radial axis, they are shown starting from the center. Then the final chart type, the box and whiskers chart. Here you can represent your data with quartiles and extend them with whiskers that show the variability. The items in a series are drawn to categories like with bars. The values for a set are given so that first you define the lower extreme, which is also the whiskers, and then lower quartile, median, upper quartile, and finally the upper extreme. Now that we've covered the different chart types, let's move on to the axis types and legend. With charts, we have these 5 axis types: the value axis, category axis, bar category axis, date-time axis, and block value axis. The category axis has named ranges and adjustable range width as shown in this picture. The bar category axis is similar, but the range which is the same for all ranges. And you can define multiple axes to one chart, and the position can be defined so that it's down, up, left, or right. And if you define multiple axes to one chart, they can be of different type, for the exception of combining logarithmic axis with a non-logarithmic one. That's something that is not going to work. A chart can also have a legend. It is drawn by QChart by default, but you can also draw it manually by setting a new parent for it. The position of the legend can be below or above the chart, or then right or left to it. The legend can also be detached from the chart so that it's a separate window that can be moved around freely. It's possible to hide individual markers from the legend or hide the whole legend. With charts module, you get the legend and legend markers examples that show how the above mentioned functionality work. Next, let's see some interaction related things and something about the look and feel. First, I will show how dynamic data drawing happens. In this demo, a random value is added to the Spline series. At the same time with adding the value, the chart is scrolled. So the data is drawn on the fly here. And you can implement a drill down effect, for example, to pie chart or bar chart. Here the effect is implemented to a pie chart. So when you select a pie slice, it will sound to a more detailed data on that slice. Basically what happens here is that the first series is removed and another one is added. Then we have an example about zoom and scroll functionality. We'll make this a bit bigger so you can see it better. The chart has functionalities for zoom and scroll. In this example, those are used when pressing the keys. So the arrow keys scroll it from left and right or up and down. And then with minus and plus keys, I get the zoom functionality. Here you can also utilize Q rubber band, so you can select the area you want to scroll into. The example also uses gestures for panning and zooming, so you can check out those with the touch device if you want. Next, we have the call out demo, which shows you how to utilize the clicked and hovered signals. Here an additional element is drawn when hovered over the series, and if I click on the series, the element stays there. Like that. Okay, now we could check how you can modify the look and feel of the chart to fulfill your requirements. Like with data visualization, charts also has predefined themes. And this application shows the themes available. I can show you a couple of different ones from here. If you want, you can easily modify the pens and brushes, or even modify the chart source code and add new themes that way. The user can, for example, change the color and the font of the labels and the titles. Also, the color of a series can be changed. And the user can hide and show titles, axis labels, legend items, and series. So there are a lot of options to customize the look and feel of a chart. There are also animations available that one can use. I will show you how the series animation works. So when I resize a chart, it will animate the series. So here you can see it for all the chart types and the series happening like this. Okay, now you hopefully have an idea of what charts has to offer, and it's time to move on to see how you can start using QCharts. The QChart is built as any other project. You run QMake for the project file and then make to build the project. QMake generates the default make files. So generally, that is the release build if you are using a precompiled Qt binary distribution. You can also define with configure the desired build if you want it to be debug, release, or both. And the configure can also be used to determine that charts should be built as static library. And to install the module to Qt directory, you should run make install. And when you need it to be removed, make uninstall does the job for you. In order to use the module in a new project, you add config plus equals Qt commercial chart to your project file. In addition to including needed C++ classes, you have to add the Qt commercial chart use namespace macro. And for QML types, just import the Qt commercial chart module. And that covers it up for Qt charts. Now back to Sami, who will summarize this presentation.
Okay, thank you, Titta. Yeah, so the charts is, as mentioned, meant for Q4 and Q5, supports both of those, and is based on the graphics view framework. And the 3D data visualization is built on top of Q5, and it does require a good OpenGL support from the hardware and the operating system. It is supported also in mobile platforms and also in embedded devices that provide OpenGL support, as well as, of course, desktop systems. But that is a prerequisite for using the data visualization. And also, some of the customers have encountered some problems related to the OpenGL that they have in their systems. Of course, we try to identify supported OpenGL features as much as we can during the runtime, and some of the features and functionality, for example, shadows, are disabled based on the OpenGL support in the system. But there are some cases that all unsupported features cannot be identified during runtime. Both of these visualization provide C++ and QML support, as mentioned, and it must be noted that the API for these products is different, so they are not interchangeable in a sense that you have to modify the application source code a bit if you transfer from 2D charts to the 3D charts and vice versa. There are different chart types and also different axis types, and there's a lot of customization options for both of the axis and the content of the charts, and also the colors and general look and feel. And creating interactive user interfaces for viewing data is one of the primary goals that we have in providing these components. The documentation for these components is available in qtdti.com documentation site, and so you can take a look to the examples that we have provided as part of the delivery, and also take a look what kind of code is needed in order to provide this kind of visualization by using these components. Both of these components are also available as evaluation versions through the evaluation download of Qt Enterprise or Qt Mobile. So you can take a look and try it out if it's suitable for your use cases. We are working at the moment with providing new versions of both of these, So data visualization 1.1 release should be coming out within June timeframe, and also 1.4 version of the charts should be coming out around the same time as the data visualization new version. Okay, and that concludes the presentation, and we have received some questions. So let's start going through the questions, and please post the questions to the Q&A box if you have more. So there's a question: can you custom draw on the surface to highlight a region? For example, allow the user to specify a region of interest. Actually, we are providing functionality for drawing custom objects on top of the graphs in the next version, so in the 1.1. So that could be used as highlighting areas in the surface graph. So basically, it would require an implementation of custom input mechanism and then drawing custom elements on top of the surface graph. With the 1.0 version, that is not yet supported. Then there's a question: can you set up the data visualization to do an orthographic view, so without the perspective of the data, specifically top down? At the moment, we are using the orthographic view only in the 2D view, so the slicing view is orthographic, but at the moment we don't support any other orthographic views to the data at the moment. We will make a note that this as a requirement candidate. And there's a question: is 3D data visualization accomplished through traditional OpenGL or shaders? Yeah, we are using a lot of shaders in the implementation of data visualization. For Q charts, how easy it is to create custom series, specifically creating a combination of the spline and scatter series. That is supported by already, so you can mix different chart types on top of each other in the charts. This is not true for the data visualization, so this applies only to the charts. So, for example, combining a spline and scatter series is possible. And what kind of metrics do you target for real-time surface? For example, with 32 columns, how many samples per second with reasonable desktop hardware? We have been testing the performance, for example, by using Microsoft Kinect depth sensor data, which is actually quite nice test case. So that gives us 640 times 480 matrix of depth values 30 times a second. And in desktop hardware, that is something that this can handle. Then there was a question about the performance of the XYZ scatter plot. Does it support tens to hundreds of millions of data points with attributes? But that kind of data amount is something that is actually quite difficult to draw simultaneously. So that kind of use case would definitely need some kind of customized data proxy or some kind of data caching functionality. So definitely in that use case, drawing hundreds of millions of data points in a scanner would bring performance problems in the current implementation. But regarding to the performance, there was actually a blog post by Mika Salmela in the Qt blog about the measuring the performance and some tips and tricks how to optimize the performance. And there's also an inbuilt FPS counter. So you can do measurements with your use case and with your data by enabling the FPS counter in the application and see what kind of data refresh rates you are getting in your use case. So please take a look at the blog post in the Qt blog. Then there's a question, which product would you recommend for visualizing arbitrary, large, rapidly updating 2D only datasets? Of course, if it's 2D only, then it would be more natural to use the charts component. But of course, depending on what is meant by large and how rapidly updating, there might be problems in performance if all the data is drawn simultaneously. But that is something that needs to be kind of smoke tested a bit. So on the target hardware and with the target use case. Then there's a question of what is the footprint of each Qt data visualization and charts? Have you done any benchmarking for use of these in embedded systems? We have been testing both of these in the embedded systems, and for example, these are tested in the Qt Enterprise Embedded offering that we have. So all of those hardware that we have in the reference platforms in the Enterprise Embedded that have OpenGL support, we are also doing testing. I can't remember the footprint of each of these components by heart, unfortunately. We have to check those and get back on this issue. But specifically in the embedded systems, of course, they have in many cases a limited hardware and also the hardware acceleration support. So, for example, drawing large data sets and rapidly updating is not supported in some of the embedded devices. Then there's the question, can we have two surfaces showing simultaneously on the same context with axis and labels turned off? Yes, that is supported at the moment. So you can draw multiple surfaces on top of each other. And you can turn off the axis grid and also the labels so that you show only the surface data. I think we have gone through all of the, okay, new questions. What are the input data formats supported? In the data visualization, there's basically this data proxy model, so that we provide a couple of common data proxies. So, for example, if you are using a QML list model or QML models, you can take directly model, for example, same model that you are using in a table view control, and use that in a data visualization and draw the data. And also in C++, item models are supported. And then there's, for example, the height map model, so that you can provide an image file that contains the height data and the depth map data proxy can draw that directly. But that is also kind of depends on the format that the data is in the application. You might have to create your own custom data proxy for handling the data. Then there's a question: when multiple charts are embedded in a larger windows, can they be independently manipulated, panning and zooming, etc., by mouse and touch? Yes, you can place several chart kind of windows in, well, chart areas in the same window that have independent input mechanisms. So it's always per chart. And of course, if you draw several series in the same chart, then the input is handled for those all that are included in the one chart. Is there any other questions, or would you like to have more detailed answers of some of the? Okay, what about updating the data in a background thread? Yes, that is also doable. So inserting new data or removing data from the chart is possible during the runtime. Any other questions or more details to the questions that were handled? Okay, if there are no more questions, I think we can conclude the session. And thank you for all participants. And if you have any questions related to these, if you are an existing customer, you can use the Qt support to answer questions, or then there's also a contact form in the Qt Digital pages. So please use that form for sending questions and feedback.
Tommy, can you hear me?
Yes.
Okay, I see a question from one person. Is there volume rendering and Qt database migration module?
Okay. I missed that one.
Yeah, as soon as you mentioned, there is no more questions. So.
I'm still missing the question. I can't. Can you, Iris, can you read the question?
Absolutely. So the question was, is there volume rendering in Qt data visualization module?
No, volume rendering is not supported. So basically, what it supports is the using of custom mesh objects in the charts, but directly rendering volume images is not supported. And of course, as mentioned earlier, the next release will contain also the possibility to create add custom 3D objects inside the charts. But as such, volume rendering is not supported.
There's another question here. Can Qt data visualization edit the displayed data set, or is it static?
Sorry, can you repeat?
Sure. Can Qt data visualization edit the displayed data set, or is it static? I believe what he means is can it be live data coming in, or is it static?
Yeah, definitely live data can be drawn. For example, the Kinet example that we have been showing in some of the events is an example of rapidly updating data. So definitely not only for static data, but of course there are boundaries in the amount of data flowing in and also the speed of the updates. And also there's a oscilloscope demo application or example application included in the example set that is provided as part of the data visualization. So that also shows how you can implement that, and also there's a kind of possibility to test the performance in the target environment by using that example.
I'm not sure if I've seen that before yet, but yes, the Connect demo where it's feeding off of live, movements is really cool and interesting.
Okay, there's actually one question more. Can the data visualization interface be also used to edit the dataset, or is it only to display the data provided? The editing has to be implemented inside the application that is using the data visualization. For example, if you are implementing a QML-based application, then you can, for example, use the table view QML Qt control for editing the model, and of course in the C++ side, you can also use the table view to edit the data. Okay. So, if there are no other questions, and we are also closing in the closing time, so I think we can conclude this webinar for this point. And thank you for all of the participants.
Thank you.